Hey there, Mr. Sutton here, bringing you the IM384 Extra Practice Number 4 solutions on independent and dependent probability. Let's check out the puzzle that goes with this extra practice. So here's our puzzle. We're trying to figure out what did the teenage yardstick say to its parents. The idea here is we have a bunch of different probabilities to find, and once we find them, we're just going to put them below the answer in this grid below here. So this is the grid for, well, 1 through 3, I guess. And then down below for 4 through 6, there's a totally different grid. If we combine these two grids, it'll come up with the whole answer for us. So let's get rolling and see what the yardstick has to say to its parents. So for question 1, just to kind of get the lay of the land, we have two different spinners going on. And the first one has some different colors. The other one has X's and Y's. So for the first thing, we have the probability of spinning blue on the first spinner and X on the second spinner. Now, the way that all of these problems are going to work for this question, since we're dealing with these spinners, what I get on one spinner has nothing to do with what I spin on the other spinner. These are independent events. One does not affect the other. So because these are independent, that means I'm going to calculate each of the probabilities individually without even looking at each other, and then we're going to multiply those probabilities together. So we have the probability of blue. We have 5 total possibilities. Blue is one of those 5 possibilities, so 1/5. And then for X, there's 3 possibilities. X is one of the 3, so we have 1/5 times 1/3, which comes out to 1/15. And 1/15 is right down here, so this was problem A, so we'll put an A down there under 1/15. For problem O, we're asking for the probability of not red and X. So not red would be everything except for these 2 reds, so there's 3 not reds right here, 3/5 probability there. And X is again a probability of 1 over 3. So we've got 3 over 15, which I can reduce to 1/5. So 1/5 is O. Now we want the probability of red and X. Red is a 2 out of 5 chance. X is still 1/3. So this is going to be 2 over 15, which is right there, so that's T. Next up, we want probability of not white and Y. So there's 2 white spaces here. That means there's 3 that are not white, so that's 3/5 for that first one. And then for Y, 2 out of the 3 spots there are Y's, so 2/3. So then this is going to be 6 over 15, which I can reduce by 3's to get 2/5. And then 2/5 is right here, so that is going to go with this D that this problem corresponded to. For problem N, we're looking for white and Y. There's 2 white spaces, so 2/5. And then Y, there's 2 of those as well, so 2 out of 3 for that other one. Multiplying those, we've got 4 over 15, which I can't reduce. 4/15 is right at the end here, so that's an N. For problem I, we want not blue and Y. There's only 1 blue space, so not blue means we've got 4 out of 5 chance, and Y is still 2/3 probability. Multiplying these out, we have an 8 over 15. 8 over 15 is the very beginning, so that's an I. For problem number 2, the next several parts of this, we have a spinner this time and a die, a 6-sided die, hopefully a fair one. So our spinner has 2 black spaces, a white space, and a striped space. And the die, again, you have 6 numbers there. So these are going to be independent probabilities when we spin and roll both of these, because what I spin on the spinner and what I roll on the dice, they have nothing to do with each other. So we want the probability of getting the white space and a 4. So probability of white, that's 1 out of the 4 equal area options that I have here, so 1/4. And the probability of a 4 or any other number 1 through 6 on that die is going to be 1 out of 6. 1 over 6 and 1 over 4 multiplies to give us 1/24. and 1/24 is right over here, so that's an A right there. For problem 2t, we want white and less than 5. Probability of white is still 1 out of 4, no change there. Less than 5, there are 4 numbers, 1, 2, 3, and 4, that are less than 5 on the die. So that's a 4 out of 6 chance of that happening. This multiplies out to 4 over 24, which I can reduce by 4s to get 1 over 6. So that's going to be a t right there for 1 over 6. For this next problem, we want black and 2. There's 2 black spaces, so that's a 2 out of 4 chance there. For a 2, I just have a 1 out of 6 chance, like any other number. This multiplies out to 2 over 24, which reduces to 1 over 12. So that's 1/12, getting an S. For problem 2W, we want not white and odd. Not white, well, there's going to be 1, 2, 3 spaces that are not white, so that's 3/4. And odd, that's 1, 3, and 5 on the die, so that's going to be 3 out of 6 options. So we have 9 over 24. If I multiply that, I can reduce those by 3s to get 1 over 8, or 3 over 8 rather. 3 over 8 is going to be right here, so that's a W. For 2n, I want striped and even. There's only 1 striped spot out of 4, so 1/4. Even numbers, I've got 2, 4, and 6, so that's 3 of the 6 numbers being even. 1/4 times 3 over 6, I've got 3 over 24. Reduce that by 3s to get 1 over 8. 1 over 8 is right over here, so that's n. For problem 2o, we want green and odd. Well, there's no green spaces here, only black, white, and striped. So there's a 0 chance out of 4 of getting green. Odd is still 3 out of 6. But 0 divided by anything and 0 times anything is still going to give me 0. So that's my probability. No chance of this happening. So we're putting an O in 0, which is kind of poetic. For this next one, problem 3, we have some word problems. So Kareem steps to the free throw line for 2 shots. Probability of making each shot is 3/4 apparently. We want the probability that he will make both shots. Well, these are independent events in theory. I'm not really sure that that's true to real life, because I'm thinking like maybe if you make the first shot, you feel more confident, and make the second one makes it the second one a little easier. And if you miss the first shot, I would think that might hurt your confidence. I don't know. But let's just say it's independent because there's no other thing to go on here. So that means we have 3/4 times 3/4. So that's going to be 9 over 16, which gives us this spot right here getting an N. For this next problem, we have Dr. Socks driving through 2 stoplights on the way to work. First light's green for 20 out of each 60 seconds, out of each minute. The second light's got 35 seconds green out of each minute. What's the probability we're hitting 2 green lights? So let's say that these are independent probabilities, just to make our lives a little easier here. Your outcome for one of them doesn't really change the probabilities on the other one. It's still, the light still functions exactly the same regardless of whether or not you hit either one of those. So we can say we have a 20 out of 60 chance for the first one, multiplied by a 35 out of 60 chance for the next one. To make my life a little bit easier, I'm going to reduce these before I multiply. So 20 over 60 I can reduce to 1 over 3, and 35 over 60 I can reduce that by 5s to 7 over 12. Now multiplying straight across, this is going to be 7 over 36. So that's right here, that's a T. So now we're on to the next set of problems. I'm dealing with this set of numbers down here that we were not dealing with before. So kind of starting over, but whatever we get from this, we're going to put together with our answer on that last puzzle to get the answer for the whole thing. Anyway, the setup of this problem is we have these 8 letters on cards, and we're picking a card, not replacing it, then picking a second card. So for all of these experiments, because I'm not putting the card back, that means that these are going to be dependent events. What I pick on the first card is going to affect my options for the second card. Since I'm not replacing that first card, I can never pick it again. So in this case, for letter O here, we're trying to pick a V, then a K. So the probability of a V, that's 1 out of 8 cards. And for a K, there's only one K, but now since I've picked one of the cards already, that means there's only 7 cards left, no longer 8. So 1 out of 7 is my conditional probability that I'm multiplying by this time. So this is going to be 1 over 56, which gives us an O right here. For the next problem, I'm picking an A, then an R. So initially there are 1, 2, 3 A's, so 3 out of 8 chance there. After I take one of those, there's 7 letters left. For R's, there's only 2 of those, so 2 out of the remaining 7 cards are R's, so multiply by 2 over 7. That's going to be 6 over 56, which I can reduce by 2's to get 3 over 28. 3 over 28 is going to be right here, so that's a T. For problem 4E, I'm picking a D, then an R. So there's only one D, that's a 1 out of 8 chance. Once I've taken that, there's 7 cards left. For the R's, again, there's 2 of those, so 2 out of the remaining 7 that I'm multiplying by. So this is going to be 2 over 56, which reduces to 1 over 28. And that is right here, so that's an E. Next up, I'm picking an R, then not R. So initially there's 8 cards and 2 of them are R's, so that's 2 out of 8. Once I've done that, there's 7 cards left, and we've already picked an R. So there are, let's see here, 6 cards remaining that are not R's. There's still one of those 7 that's an R, but 6 are not. So 6 out of 7. So we have that being 12 over 56. Can reduce those by 4's to get, let me think, this is going to be 3 over 14. So 3/14 is right here, so that's a Y. For the problem 4N, I'm picking an A, then a V. So I've got 3 A's, 3/8 chance of getting those 3 A's. Once I've taken one of those, for V's, there's only one of those, and there's 7 cards left, so 1 out of 7. So then this is going to be 3 over 56, which I can't reduce anymore. That's going to be right down here, getting an N. For our last encounter with aardvark, we want A, then not A. This will be a little bit tricky. The first A, we've got 3 A's out of 8 total cards, so 3/8, that's not so bad. But then if I want not A, what have I got? So there's 7 total cards. And out of those 7 total, one of these A's is gone. So that means there's 2 A's left. That means there's 5 cards that are not A's out of the remaining 7. So 5 over 7 is what I'm multiplying by. That's going to be 15 over 56, which I don't believe I can reduce at all. Let me see if I can find it down here. Yep, 15 over 56, so that's an E. For my next set of problems, number 5 here, we've got these marbles, of which there are 9. We've got 4 greens, 2 reds, 3 yellows, and I'm picking 2 marbles without replacing the first. So again, since there's no replacement, my first pick influences what I can get for my second pick, so we're going to have dependent events going on for all of these problems. So we've got 5T, we want red, then green for this problem. So for the reds, again, there's 2 of those out of a total of 9 initially, so 2/9. Then greens, we've still got 4 of those out of 8 remaining marbles, so 4 over 8. This all multiplies out to 8 over 72, which I can reduce by 8s to get 1 over 9. So that's going to be a T for 1/9. For this next problem, we want yellow, then not yellow. So initially I have 3 yellows out of 9 marbles, so 3 out of 9. Now for not yellows, I've got 6 of those, and none of those have been picked yet. But I've only got 8 marbles left. So 6 out of 8 for not yellow from the remaining marbles. So that's going to be 18 over 72, which I can reduce by 9s to get, well, actually, I can reduce by 18s, actually, right? This is 1 out of 4. So that's going to be right there, F. For problem 5E, I want red, then yellow. So we've got 2 reds out of 9 marbles, and then 3 yellows out of 8 remaining marbles. So that's going to be 6 over 72. I can reduce those by 6s to get 1 out of 12. And 1/12 is right here. So that's an E. For problem 5R, I want a green and then not a green. So we've got 4 greens out of 9 marbles right off the bat. And then once I've taken one of those greens, there's 5 marbles that are not green, but now there's 8 marbles total left. So 5 over 8 is what I multiply by. So that's going to be 20. Now we got a couple problems 72. That are word problems for number 6. Which I can reduce by 40 tickets sold for a raffle with 2 prizes. You buy 2 18. Tickets. We want the probability so will win both right prizes. That's an R. All right, so this is going to be dependent Next events. Up, we want green, then green. So after initially you win one of the prizes, out of 9, that means that then after I take that, I've got left 3 greens so that influences your options for the second 3/8. So initially you have 12 out of 40 72. So a 2 out of 40 chance of winning 12 that first give prize. Me 1 over 6. Once you win that, assuming you win 1 over 6, you have right there. That's 1 ticket left, and there's 39 total left. And then finally, draw last problem 5 so part. That's going to be a 1 out of not 39 red, chance of red. And this so then comes initially out to 2 we have over 7 whatever 40 times that are not red 39. Once so I take one of those, here. There's 6 not actually I could reduce this a little bit. 8 marbles. So we've got 42. Whatever. Let's just use 72. So we've got 40 times 39 for that denominator. I think by 2, giving me 1560, so 21 over 36. But then I could go further. And, so what can I actually reduce divided by 2? If I reduce those by 2s, that gives me 7 over 780, which is thankfully one of my answers right here. So that's a W. E right there. Now we come to our final problem. 2 cards drawn from a deck of 52. And then, assuming we're not putting any of them back, what's the probability that both cards are aces? So we've got, again, dependent if I'm not putting them back. So we have how many aces in a deck? That's 4, I believe. So 4 out of 52 initially. And then if I take one of those, there's 3 left and 51 cards left. So 3 out of 51. So this is going to be 12 over whatever 52 times 51 is. Let me go to the calculator for that. 52 times 51 is 2652. So we have 12 over that. And what can I reduce that to? Well, let's see here. 2652, is that divisible by 12 itself? It is. Oh, so this is going to be 1 over 221. That works out. So 1 over 221 is right there. That's an H. And now we can go and solve the puzzle. So now we can go ahead and solve this riddle. What did the teenage yardstick say to its parents? And it's all written out here with the spaces already included, so we don't have to interpret or anything. The teenage yardstick said, I want to stand on my own 3 feet. Oh, okay. He's being all rebellious and whatnot. Okay. Until next time, Mr. Sutton signing off.